everyone, welcome back. Today we're going to be going back about 4.6 billion years, a little less than 4.6, to the beginning of Earth. So I wanted to talk about Earth first before I talk about the whole solar system and how the sun and the solar system was created, because, this is our home, and so it just might be a little easier to connect the dots after you see what Earth was like, because a lot of people tend to think of Earth as it is now back then, and that's not what happened. It took a long time for it to get to how it is now. So we are going to start with the beginning. So I obviously I can't bring up the creation of Earth yet until I talk just a little brush on how the rocks even got there. But there will be another video explaining in far greater detail the actual process by which the solar system itself was created. So, first you have a nebula, and as you can see all around us in the Milky Way, there's a ton. There's a lot of dust, a lot of particles, a lot of new stars we see out there. And as we look at other new stars and how they were created, that's how we got the idea of how ours was. The nebula started gathering particles, or all of the particles that started interacting. They began colliding and creating bigger particles, and eventually, when it got heavy enough, it had enough mass that it started to create the fusion process, and that is what creates the sun. That's how the sun is. It's a fusion ball. So when that happened, the materials around this newly formed sun were mostly dust and other smaller particles and rocky substances. So this is just a little artist rendering of what the early solar system could have looked like. And this is just to get some visualization. This is not intended to be extremely accurate. But as you see, there's a lot of rocky, and there would have been a lot more dust. And so what happens is that this nebula started out as a big, probably a globular shape, and it eventually collapsed down to make the sun. And when this action happens, it's pretty violent. So it starts spinning, and all of this spinning, makes this like a disc. And we call that the accretion disk. And the dust and particles start gathering together, becoming larger and larger, and eventually they start to gain some mass, heavier mass, and became more spherical. Now, there were several theories on what the early Earth actually was, and if it was destroyed, if there was a planet that was the base of Earth and then it got destroyed, and started gathering up the other ones that were knocking chunks off of it and just became a bigger and bigger mass. But for now, we'll just stick with the process of how these happen. So, when these collide and merge, they are growing into planetesimals. And these are really small rocky objects, probably like these that we're seeing over here. And then as they become larger and start gathering more, or start attracting more rocks to them, and then they become protoplanets. And so these planets aren't like, they don't just form and then they're ready for life and everybody can live there and life can start evolving. Yeah, that's not how it happens. So, first, what happens is the planet, the protoplanet that exists there, is now really hot. It's been just colliding things into it, and it started. It started from an iron towards the center. That's why our the center of the Earth, the core, is molten iron. And so this iron and heat that's generated just continues. And as things are getting pummeled into it, the heat just continues to generate. And essentially, it's just this big molten lava world. This is not a world that you'd want to live in. This is just volcanoes everywhere, rifts everywhere. Not habitable. And so through this time, after the formation of the other planets, and now the asteroids have kind of not just around for the taking anymore, then planet Earth starts to cool down a little bit. And again, this takes a long time. So me saying, oh, this just happened, the time scale is way longer than any human life. So after it starts to cool down, then the particles that were gathered through the process of making this protoplanet start to be able to come into play a little bit. So it's believed that hydrogen and oxygen were present during the formation of this protoplanet, but they couldn't really take any effect to create water until the planet cooled, because obviously you can't have, a newly forming pond on the top of an active volcano. This just goes over how the planets formed where they did. So here's something that we know, and then things that we've found that kind of go against that. So Jupiter is, obviously this is not to scale. Jupiter's out here on the other side of the asteroid belt, further away, and it is a lot of gas, a lot of helium, hydrogen, and then you have the rocky planets inside. So one of the early solar system theories was that these four, Mercury through Mars, were not the only rocky planets. There were several other ones, and they got either eaten by us, or they got, flung into Jupiter out of their orbits, because even though this isn't to scale, things in between our size of Earth and Mars and our distance is a little close for comfort. But the asteroid belt is kind of evidence of not only the early solar system not having all of its asteroids collide, but also um, damage that was done along the way to create these four inner planets. But we've also seen some Jupiter-sized and Jupiter gaseous planets in closer to their sun, like as close as Mercury in some cases. And these are called hot Jupiters. We know that Jupiter-sized planets cannot form that close to their sun. So the theory is that those planets, because they're so attracted to their star, because both masses are very large, that they moved inwards and then ate the rocky planets that did form there, if they had any chance to form there to begin with, and then just took up shop and settled in their close orbit. And there's also reasons that I cannot explain yet, but that I have watched other scientists explain for why our Jupiter hasn't. It could be because there's that buffer zone there with the asteroid belt, and that they are kind of further away from each other, or that you have these larger masses out here, Saturn especially, pulling outwards, even though it wants to go inwards toward the sun, and so it kind of keeps it on a slightly more stable orbit than these other much older planets. But whatever the reason, this is our makeup now. And Earth is here in this really comfortable zone. So the early solar system here, again, not exact, but the early solar system here, this inner section started to take shape with however many other planets, including Earth, in there. Now, if something happened in the minuscule amount of time between the sun and the Earth being made, that's not something that we can find just yet. See, when we look through telescopes like JWST and now Rubin, and we look back in time, we're looking really far away. But we're here, we're right here, so this is present day, and can't look back in time in your own sun, in your own solar system. Things happen here, and they happen. We see them, and then, maybe if there's people far away looking back at us, then that's a different story. But moving on with the actual creation of Earth through the accretion that I was showing. Where was that again? Where's my little button? There we go. So, yes, there we go. So the heavier materials, like, the rocky terrestrial stuff, settled in, moved in, created the planets that we see now. Oh, I keep going the wrong way. Okay, so this cooling world became not yet able to rain. It was cooling. It's creating an atmosphere. Particles are sticking together, the hydrogen, the oxygen. It was also very heavy on carbon dioxide and methane. And they started creating an atmosphere that couldn't yet rain because it was still too hot. So it cools, and then eventually it becomes just a huge thunderstorm. a thunderstorm that rained until the entire planet was covered, and basically all you could see were the tiny islands that stuck out from the highest peaks that were created during the lava world. And so there's a story from Nova, which is through PBS. In America, that's public broadcasting system. Although the Senate, I believe, is voting to cut funding to public broadcasting, which actually brings a lot of education to kids. So that's a little disappointing, to say the least. But this is a really good, just really simple and also very short breakdown of the water world. There are some things that they don't say, but they do still say the minimum, I guess. So, as we see here, they also say that it's possible that the solar winds pushed additional hydrogen and oxygen towards the planet, and likely that even more arrived in rock form. So, as we see from testing asteroids and as we see from comets, water can exist just on rocky objects out in space, so that also makes sense. And so in this article, it also just basically says what I also just said, that there was a lot of atmosphere building during the cooling down portion, and then eventually the Earth did cool enough to where it could start raining. And so this just breaks down mostly the atmospheric, how rain droplets form, and then, as it says here, eventually Earth had released enough of its heat into space for liquid water to remain. So one of the details it doesn't say in this article, because again it's just a little just a short explanation about how the water world was possibly formed. So one thing that they don't say, though, is that the sky wasn't going to be blue like our sky is now, because there's a lot of carbon dioxide and methane, as I stated before. I mean, you've had lava and these chemicals being just thrown into the air. So this early atmosphere was not the transparency we see today. And the oceans were not, well, the water wasn't clear, because again, if you go to the beach and you scoop up some water into a glass jar, it's not going to be blue. It's blue because it reflects the sky. And these ancient oceans that covered the earth, I think it was 96% of the earth, were actually very green, because they were heavy in iron. This one shows you the timeline, and so this is the period that I'm talking about. So it looks like there was a lot of cyanobacteria during this portion, and this image comes from studyiq.com. All of the links will be posted as well, so if anybody wants to go back and look for themselves, go ahead. And so this is the little islands. Again, this is just a representation, but there's pretty good evidence for a lot of this placement. So these are the little islands that cropped up after the millions of years of rain. And this color, this cyan greenish color, that is about what it looked like. So actually on my screen over here, it's blue. But on my screen here, it's cyan. So if it is to you as well, if it's cyan, that's about the color it was. It was greenish. It was like a greenish color. And these little islands still were wanting to create more land and still needing and wanting to push more lava to the top. So it began erupting again, and a lot of this ancient water can actually be found in the zircon crystal, which is zirconium silicate. These are very old, and they have evidence of these, fingerprints of old ancient ocean that existed here. So these continents that started forming after the lava, then after the rain and more eruptions, these were actually all granite, and it became just, a granite planet. A granite planet. So granite is actually lighter and also tougher than basaltic rock, and so this granite was ideal for making these continents. I am so sorry, you guys. I'm actually really tired, but I didn't want to go another night without making a video, so just gotta bear with me just a little bit. Just a little tired. So, yeah, so these old continents that began forming were granite. Then you have the formation of more land and more organisms, and this large supercontinent got in the way of the Earth's, just how it was naturally moving the water, and started to freeze. And so when it did that, I have a feeling these numbers are slightly off. I'm going to go back and recheck that. But when the Earth began to freeze, it froze everything. It froze from top to bottom. The entire planet was frozen. This was the largest freeze the Earth has ever experienced. And so they just call it Snowball Earth. It's very creative. And I find Snowball Earth very interesting, to say the least. And so when the Earth became this snowball, and so over here, this image has the Earth over here, the moon over here, not the Earth. But I don't have enough information yet about when the moon was actually created. I do have some resources. I'm going through them right now. That'll be a different video. But yes, this Snowball Earth was very thick snow, very thick ice. Very little snow, actually. Very thick ice, because as you can imagine, a lot of the world was water, which means that the water that froze, there were some organisms that that survived, obviously, because they could, probably get deep enough, and the closer you get to the bottom of the ocean, in a lot of places, the warmer it'll be because you're getting closer to the mantle, especially deep, deep ocean. So over here at Harvard, the Harvard Gazette, they actually did their own story about how Earth may have been a water world 3 billion years ago, but this was released in 2021. So now this is all known. So according to this Harvard Gazette, the Harvard-led study, geochemical calculations, placed Earth's primordial oceans 3 to 4 billion years ago. So in these primordial oceans, that's when those first single-celled organisms began to develop. And these organisms then, after this heavy freeze came and went, these organisms that then started becoming hotter again because it started warming, melting the ice, and started reigniting the volcanic activity of the planet. That gave way to these organisms then becoming even larger. And so once organisms started to evolve and become more dominant in both the oceans and then later the lands, then you start to see blue oceans, because once ancient plants and anything that is going to capture that carbon dioxide, as soon as those things started forming, they started being able to clear up the atmosphere, and these organisms in the water started to clear up this water. And so this iron actually settled down and just was pushed down. And so what a lot of people don't know, or don't see if they don't look, I guess, is that a lot of the iron that we mine now was all from this time. This very first ocean that was heavy in iron, that iron then settled and created the band that we now mine for and use in, a lot of different things, from cars to bookshelves to our computers. Iron is used in a lot of things. So we can also see iron. We have iron in our blood, and we need iron in our bodies. So this early iron actually was very important. So in this, it's showing you what kind of life would have been here at what times. And so now at between 1 billion and 500 million, you've got this good amount of vegetation, and the oceans are now turning blue. And these continents are the original supercluster. The original supercontinent had already broken up and moved apart, and now after even more volcanic activity, you start to get another forming of a supercontinent. And this supercontinent doesn't create a big snowball Earth like it did the first time. There's a lot less water. There's a lot more land now. And life has started to occur. Has started to develop on the planet. And the evidence for the supercontinent of Pangaea is found in the fossils. So all of the evidences that are found or that have been found to then confirm all of the supercontinents and what happened with the iron in the oceans and the lava planet and just the ice ages. All of these things are not actually in my department. So I am going to link or attach 2 really good videos that explain the processes of, like actual archaeologists and paleontologists and people who spend their whole lives, trying to figure out the Earth. And from here, from this forming, I will leave the rest of the forming of Earth to, the geologists and archaeologists and paleontologists. And I know a lot of you, probably every single one of you know Mini Minute Man, but he has great archaeology videos. But I am also going to share 2 other videos that are not Mini Minute Man, but they're also very good at explaining all of the Earth-based evidence for what I just talked about. As far as I'm concerned, in this chat, I focus on this portion, early solar system, and this portion, because I am a believer that not all people who study a science can just talk about any science. I can talk about them with people who know more than me. So, that's just based off curiosity. So, I hope I have explained how the Earth became the planet and protoplanet that it was. And I hope that leads well into any future videos, the linked videos, hopefully, that you might watch. One of them is a little bit longer, so you need to take time to watch that one, or just watch it in chunks. But for now, I'm going to leave the rest of Earth to those really awesome and engaging scientists, and I will stick to this portion. So I hope that I have made the understanding of the beginning of Earth easier, and this will lead into other things. So now that you understand Earth and its development, you can then go into the understanding of how the entire solar system was created, from the sun to Kuiper Belt. And that will be coming. A couple other things that I've got coming up. I am going to be having a chat about black holes. So I know a lot of people are intrigued about black holes. We'll talk about the science behind them and why they exist. So I hope that is intriguing to you guys, and I hope you come back for that. So for now, remember to like, subscribe, share my videos, and keep looking up.